Ladies and gentlemen, welcome to Griffith Observatory's All Space Considered, which happens on the first Friday of every month. And this indeed is our first Friday of the month. And today is Friday, March 5th, 2021. Can you believe it? We're already back to March once again. Welcome to All Space Considered. All Space Considered is our premier lecture series at Griffith Observatory. It's made possible by the City of Los Angeles and the Department of Recreation and Parks that runs and operates Griffith Observatory. It is also made possible by the Griffith Observatory Foundation that makes so much of what we do possible. Joining us tonight, and joining me tonight, is Chris Butler and Patrick So, of course, who's always with us here at All Space Considered. But we also have a couple of special guests tonight, and we'll get to that in just a second. But we have a really, really fun show for you all. We're going to talk about the Parker Solar Probe and a wonderful image of Venus and Orion that's in there. Proxima Centauri and a new exoplanet, maybe around one of the Centauri system stars. Juno had a 32nd perijove. Juno's turned 32. That's incredible. Then our first special guest, Anne Marie Betke, the executive director of Griffith Observatory's Foundation. You're going to hear all about what the foundation has been doing for Griffith Observatory and what we've been up to this last year and how it really makes a difference for us. Then we're going to turn to Chris Butler, where he's just out to launch, as always. I think we're going to have to keep the section titled that. And then we're going to turn to the Super Bowl of Astronomy, wrap up our Golden Griffy Awards. But, you know, I'm going to do a quick job on this, mostly because we have pretty pictures with Katie to get to. And then after that, we have highlights from Perseverance, which if you haven't been paying attention, we've got our new rover on Mars, and we have a special guest Q&A session with NASA JPL's Nagi Cox. She's the Engineering Operations Deputy Chief of the Perseverance mission. So we have a very special guest, so we're going to get to that fun tonight and talk all about it. And thank you all so much for joining us tonight. So let's start off tonight with the Parker Solar Probe and Patrick So. Patrick, what's the Parker Solar Probe been up to?
Well, it's been up to a lot of things, but its primary mission is to study the sun up close. And it's kind of slated to get as close as 3.9 or actually 3.8 million miles from the sun. That's as closest any sun probe has ever got to the sun. But it actually has an orbit that takes it close to the sun and then takes it far away from the sun. And last year, it made its third close flyby of Venus. It uses Venus as a gravity assist to kind of fling it closer and closer to the sun with each pass of Venus. Now, the probe has a very special camera. It's a wide field type of camera. And the scientists decided, well, we're going to fly around the night side of Venus. Let's see what we can do. So I was kind of interested because I looked at the date of this flyby, and what I did was I went to Eyes on the Solar System and was able to duplicate what Parker Solar Probe would see as it flew into the shadow of the planet Venus. And you can see Parker Solar Probe silhouetted against against Venus, and there's very starry backgrounds and stuff like that. Now, this is the picture that it took. And it is just incredible. Now, what we're looking at here is Venus is you can see the planet Venus, and there's various areas where it's kind of dark and light. And you can see all those streaks. All those streaks are cosmic rays kind of entering into the detector of the camera. But the interesting thing is that, and very unexpected, that the camera was able to see a dark feature called Aphrodite's Terra, which is a highland region on Venus, but it's actually showing through the clouds. Now, the scientists were wondering about this and they said, what's happening here? Because our camera actually is only designed for visible light. Well, it turns out that this camera has a bonus. You can actually see and peer into the near infrared. And what we're seeing there is basically the heat generated from this enormous highland region, which covers about 2/3 of the planet, shown through the clouds. Also, you can see in the picture, there's air glow there. This is the basically the oxygen, the very little amount of oxygen in Venus's atmosphere, actually recombining on the night side. And when that happens, you get a little release of light. So that's incredible. As a bonus, if you look at the starry background, there's Orion way down over there. And that's kind of like a bonus feature there. But it actually gives you a good confirmation of what we're seeing here in this picture, because if we go back to the simulation, there's Orion and in the picture in this Eyes on the Solar System. This is just really fascinating. So back to you, David.
Thank you, Patrick. That's some really amazing imagery coming from the Parker Solar Probe at Venus. To see Venus glow like that and then to see Orion, that's a little foreshadowing, actually. And folks, anyway, back to our next story. SETI Institute. If folks don't know much about the SETI Institute, it is the search for extraterrestrial intelligence. This whole game was kicked off when folks realized, we're beaming our radio waves out into space. In particular, the things that really we're doing, and everybody loves to talk about, I Love Lucy and whatnot going out there, but what really is beaming out into space is mostly radar. The radar that is sent out there to detect those World War II bombers as they were flying around was sort of the first stuff that was beamed out there into space with really strong strength. You needed to bounce it off a little airplane that was heading into England to bomb you. See, those signals would bounce off, come back, you receive them. Well, most of that radiation didn't hit the plane. It was headed off out into space. Now, if you were on a planet some faraway distance and some star was in the way, that radiation hits you. Well, it has Earth's motion embedded into that radiation. And that motion of the Earth affects the signal you get. In fact, a radio telescope like this one at the Parkes Observatory in Australia can actually pick up the drift in frequency from something like a radar on another planet. And that's one of the things they go look for to see signs of intelligent life out there in the universe. First of all, the radar actually also sends most of its energy in a very narrow frequency range. You don't want to blast a whole wide frequency range, just a narrow one, then you get it back and you get a nice clean signal. So that's what we're looking for. And it turns out that there is something kind of interesting going on from Proxima Centauri. Proxima Centauri is the nearest star to us, right around 4 light years away. 4.26, I think, is the number, if I'm remembering. We might 4.3, if I round it to the nearest one. So they've called this the Breakthrough Listen Candidate number 1. It indeed is a candidate signal. In April and May last year, they had a signal. It was around for about 30 hours. The thing is, it didn't seem to come back. The frequency of it was about 982 megahertz, for those of you that want to go searching for it. What was interesting about it is it did drift in frequency, much like you'd expect a signal coming from an extraterrestrial source. Maybe a signal coming from the nearest star. Well, you wouldn't think it'd be coming from a star, but maybe a planet. And indeed, Proxima Centauri does have planets around it. Can you imagine that? A planet and a signal, a radio signal? Well, not so fast. On the right-hand side, you can see their space weather discovery puts habitable planets at risk. Indeed, Proxima Centauri is a red dwarf. Red dwarfs give off a lot of X-ray flares, very energetic. They're tiny, but they're sort of angry, I guess. You could think of it that way. The flares and things sending that radiation out, even though it has 2 planets that are confirmed around this little red dwarf. And we think probably a ring of debris as well. Could there be life there, though? I don't know if I'm seeing any life in this image. With careful eyes, maybe you'll see a four-legged beast. Anyway, Proxima Centauri is not alone, though. It's actually part of a three-star system. Alpha Centauri A and Alpha Centauri B are much bigger stars, and Proxima is very mildly bound to the other 2. We think it's being carried along with them and on a kind of a long orbit, but very far away. However, Alpha Centauri A has always been a favorite of folks to wonder, could there be life there? It's a star very much like our own sun. Well, it has another star there, though, which made people wonder, can you have planets around a double star system? Can you have that Tatooine, so to speak, where you got 2 stars up in your sky? Well, here's the actual orbit as viewed from Earth. One is in the center here. A is in the center, and then B, if you keep A fixed, moves around kind of like this. Well, if you unproject it, so tilt it so it's face on, you get the actual shape of the orbits. And you can see it's an ellipse. Sometimes it's further, sometimes they're closer together. This distance, the closest they get to each other, is about Saturn's distance from the sun. That's far enough away that you could pack some planets down in here. You could pack an Earth in there, and this one probably won't disturb it much. So could you? Well, let's look at the habitable zones around each of them. The green around B, the blue disc-shaped, the donut there around A. Those are the habitable zones. And notice A's is very much like our own sun's, 0.9 to 2.2. Earth would fit in there. You could get a habitable zone. Mars out in the outer part of it. But you need, the planet needs to be right. It needs to be big enough to hold on to the atmosphere, all the rest, liquid water. But is there one even there? Turns out maybe. A candidate was found. A paper was published just recently where it's a Nature Astronomy, and that's a big deal, going up to the Nature Astronomy level. And you can see here, these are the two stars, A and B. The center, they've shifted the two stars relative to one another. I know I'm making laser points all over the place here now, but what they did is they had a star, they shifted the other one on top of it and subtracted it. Now, the two stars aren't equally bright, which is why you get this dark area here that's over subtracted. But it's a good way to give you a guess. You start out and say, well, you can roughly subtract these two things off of one another. Then you can make corrections to that, mathematical corrections, and you end up with something that didn't go away. Something's left behind. What would be left behind? Well, an object you don't expect. They did some work on that. How bright is that? Would they be able to pick up something like Jupiter? Would they be able to pick up something like Earth? What about something like Mercury? A whole range of things in this paper. It turns out they think this could be roughly an Earth-sized planet in the habitable zone around Alpha Centauri A. So it makes me wonder, when we look at the map here, where everything is, our sun is the yellow disk there in the center, Alpha Centauri and Proxima Centauri a little over 4 light years away. Proxima Centauri, okay, maybe you don't want to go there, but maybe that flaring star has some interesting stuff you want to go gather. Maybe it's a civilization on Alpha Centauri A that hopped in their, their star dump truck to go pick up some stuff, and they're taking it back. All right, that's far-fetched, but things have gotten interesting in the Proxima Alpha Centauri A and B system. So stay tuned for that. This is this is what I kind of live for. I love this sort of thing. I've always enjoyed the thought of, could there be life out there? It's one of the reasons I'm so interested in our main topic tonight, the Perseverance mission, that we're going to go look for those signs of life on the surface of Mars. And, we'll talk more about that tonight, but maybe we're picking up signals. Stay tuned for that. We'll certainly bring you more of the story if they're really there. Well, Patrick, talking about signals, we've been getting signals from Jupiter, from a probe that's been at Jupiter for quite some time. Tell us what's been going on there after all this time out at Jupiter.
Yeah, so this probe is NASA's Juno spacecraft. You can see in this kind of artist conception here. It's been going around Jupiter since it has an orbit about 53 days for each orbit. But when it goes by Jupiter at a very close pass, we call that a perijove, and it's done 32 of these. And I've indicated there PJ 32, that's perijove 32, where the spacecraft can glide as close as 2,600 miles above the cloud tops of Jupiter, traveling at a speed of 130,000 miles per hour. Now, it takes about 2 hours to go from pole to pole, and during that time, all its instruments are turned on, including the Juno cam, which continues to send us really spectacular pictures of Jupiter, some of the highest resolution pictures that we've ever seen. And here we're seeing a whole series of ovals there. There's actually 3 of them surrounding a kind of a dark feature here. Let's take a close look at this. These are anticyclonic features on Jupiter, and they're located in the southern hemisphere, and they're pretty interesting. And you can see all the cloud dynamics. Just as interesting are these vortices, and you can see these little white clouds. Those are ammonia ice clouds, the kind of pop-up clouds that are visible on the tops of these giant vortices. Now, this is another interesting feature that came across in perijove 32. There's 2 vortices above a kind of a dark area, and you can see that dark area, and we have an actual close-up of that. Inside that dark area, that is actually almost like a version of a whirlpool in the clouds, and you can see basically it's sucking the clouds down deep in below the cloud layers, cloud tops, so to speak, of Jupiter. And some of these features can be as large as continents or as big as the United States. Now, we've only seen a few of these pictures, but there are many more which are processed by the public. These are kind of enhanced color pictures. And you can find them on this website. So if you can't find this website, just go ahead and type Mission Juno in your search, and you can actually get to this website where you can see all these wonderful pictures.
Well, Patrick, thank you so much for bringing that as I'm sitting here trying to adjust my color. There it goes. The camera's finally fixing its color temperature for me a little bit. Anyway, these pictures are really fabulous. And folks, if you want to take time to take down that web address, you can get that down, write it down, go take a look at them. I know we bring these pictures to you a lot, but these are some of the most dramatic, emotional pictures that the space program has brought since we were watching people bounce around on the surface. I mean, yeah, I love the rovers and things, but the public was unleashed on this imagery and told to go transform it. In fact, Patrick, you even have videos on our YouTube channel telling the public how to go do that. So go download your images, tweet them at us, tell us about it, and get involved with Griffith Observatory. And speaking of getting involved with Griffith Observatory, we have Anne-Marie Bethke here tonight to join us, the Executive Director of Griffith Observatory's Foundation, with great news about what's been going on, how the Foundation's been helping us achieve our mission, and so much more. Again, I often think, can I even come up with something where the Foundation has not helped us at Griffith Observatory? And I do this just to see if I can, and I often can't. Right now, I am drawing a complete blank, yet I'm thinking of hundreds of things we do to achieve our mission. And it is made so much better due to the Foundation. Our capabilities are expanded, and I could go on forever, but let's let Anne-Marie tell you about what the Foundation's doing for us. So welcome, Anne-Marie, to All Space Considered tonight.
Oh, David, thank you so much for having me. As Dr. Reitzel said, I'm Anne-Marie Bethke, Executive Director of Griffith Observatory Foundation, formerly known as PHOTO. I'm so excited to tell you what we have been up to during closure. Can you believe it's been almost a year since Griffith Observatory has been temporarily closed to the public, however, in compliance with the city's public health and safety protocols. And while we don't have an open date yet, I want to share some of the work that's been going on behind closed doors. It's been a challenge, and I'm so proud of the team at the observatory and at the Foundation for pivoting quickly and creatively to respond to the needs of the moment while continuing to work in service of public astronomy. So early in the crisis, many observatory staff members switched gears to work as emergency service workers, really supporting local shelters and childcare centers. They made critical contributions to securing the health and safety of our local communities. The facilities team on site at the observatory have taken on major projects in the building and above and beyond usual maintenance. And guide staff have continued training so that when we reopen, they are current and ready to receive you. Last summer, the observatory began providing outdoor, socially distanced programming for the Los Angeles Department of Recreations and Parks Summer Play LA and Safer at Parks program. Observatory staff safely offered Griffith Observatory's signature demonstration, Let's Make a Comet, and other activities for thousands of children ages 6 through 14. The materials were provided by funds from the Foundation. Our primary role at the Foundation is to support and promote Griffith Observatory in its mission to inspire everyone to observe, ponder, and understand the sky. During the pandemic, that has meant providing funds for technology and specialized staff required to bring you live online programming. While this was born out of necessity, making the jump to streaming has extended the reach of the observatory's programs beyond the walls of the building, and we will continue to provide this service even when we can host live audiences on site again. Not only is this show you're watching right now, All Space Considered, now streaming, there's also been live coverage of major space and sky events, like the Perseverance landing a few weeks ago and the Great Conjunction in December, which attracted over 3 million viewers worldwide. There are more exciting events coming up, so I encourage you to follow the observatory on social media and sign up for Griffith Observatory Foundation's newsletter. I think we're dropping that link in the chat. We will keep you updated on all observatory news, including upcoming programs, updates on eventual reopening, and more. Okay, another change you might have noticed is the new website, which launched this week. If you haven't had an opportunity to pop over, when you get a chance, please do, griffithobservatoryfoundation.org. Honestly, the website, it was a major collaboration between the observatory and the foundation. However, before the pandemic, we had secured some grant funding to rebrand the foundation, formerly known as Friends of the Observatory, and create an updated joint website with the observatory. As you can see, our new logo is inspired by the iconography of the observatory's 3 domes. And along with the new name, we have made changes that really more fully connect us to the institution we all love and serve. You can learn more about our impact on the website, but it's donations and member contributions that really make it all possible. I hope you'll consider joining or even giving today. Finally, I would like to talk about our online school program. So in addition to supporting public programs that you enjoy, Griffith Observatory's school program needs your support as well. So pre-pandemic, the school program was an on-site visit, a 2.5 hours of inspiring and engaging STEAM activities, which stand for science, technology, engineering, arts, mathematics, in the observatory's exhibit halls. Live observing with observatory instruments and presentations in the Leonard Nimoy Event Horizon Theater and the Samuel Ocean Planetarium. Thanks to our supporters, we were able to provide the visit at no cost to schools or students, as well as bus scholarships for many schools. With the closure, the observatory rose to meet the challenge and has secured continuity of the program for 5th graders. The result is nothing short of innovation. We are now serving students with a live online version of the program that has the capacity to serve tens of thousands of students, more than the 28,000 we were already serving annually. I think it's time to check in with Dr. Reitzel, who's been leading this team responsible for it.
Well, hi, Anne-Marie. Indeed, I've been leading the team, who are wonderful, by the way. Thank you, everyone that's been working on this. It's just been an incredible experience so far, but we've got some neat things that have been going on. In fact, hey, Booth, do you think you can run the video we show to students to bring them to the observatory? We've already shown this to 2,000 students in our testing. We've had a whole bunch of classes come in already. And, well, you take a look. Let's show the wonderful work that I think one Chris Butler might have been involved in this just a tiny bit, so we can thank him for this in just a moment. that is just amazing to see live here at All Space Considered. We literally transport students from the depths of the Virgo cluster, which of course is on our big picture in the Gunther depths of space at Griffith Observatory. Chris Butler, wonderful job bringing those students in. In fact, I saw a name on that school bus that looked a little familiar. What's the story there, if you don't mind?
No. We're actually notorious for honoring ideas and people sometimes in our presentations. We had one of our very long-time employees, Don Dixon, was our art director for years and years, more than 30 years he was here, I believe. He just retired. And so that you will see that school bus says Dixon Elementary on it in honor of another one of our long-serving staff members who's brought so much to all the exhibits and planetarium shows over many, many years.
Yeah, and of course, those planetarium shows are made possible by Griffith Observatory's foundation, right? By the Griffith Observatory Foundation. Now, another thing that we're doing for the kids in the school program, we bring them a live telescope image. And, you know, is there anybody up there at the dome right now that can turn on a live image for us? Can we take a look at anything here? Switch that on. Okay, well, ladies and gentlemen, what you're looking at here is a live telescopic image through our famous Zeiss telescope from the roof of Griffith Observatory. That is the Orion Nebula. In fact, you know, this sort of a view, can you prove that this is live and not just a picture? Is there any way? Yeah, okay. All right, so that's a live image. Now, of course, the children are going to experience our school program during the school day. We bring them a live image of the sun, but the same technology, which is made possible by Griffith Observatory Foundation and all the equipment they've purchased for us, lets us show you this image. It's just incredible that a partnership like ours between the city of Los Angeles, bringing you the facility of Griffith Observatory, and the foundation, bringing us the tools to expand our ability and expand our reach. And that goes back to the school program. Is this new school program does expand our reach. It lets us reach more kids, potentially more kids than we could with the previous program, just like you said, Anne Marie. So thank you, crew, for bringing us this beautiful image from the roof. We'll show you it again tonight at the end of the show, so stay with us tonight. So back to you, Anne Marie. You know, just thank you so much for making this program possible for the kids.
Absolutely, Dr. Reitzel. I would love for you also to share with our audience tonight just the status of the program, where we are in development.
Well, we've finished the development of the first module, and it's been tested, like I said, in front of 2,000 kids, many classes. I think it was, gosh, around 50 or something like that. We are now developing, in coordination with the foundation, of course, the software that will help us schedule those next round of kids that are coming. We'll do some, you know, targeted invites to make sure that we test the software correctly and we don't unleash a crazy thing upon too many teachers. So that's our next step. We are also developing a comet demonstration where we're going to bring a live comet demo to you. Now, it's a little different than the one you used to see at the observatory, Let's Make a Comet, because it is, you know, again, over the internet via Zoom. It'll be live for the kids. In fact, I believe our plan will be to let foundation members be the first ones to see this new comet demo. So, you know, stay tuned for that. You're the first ones to hear this. In fact, I imagine my boss might be in the background shaking his head wondering, why are you promising this already when all you've done is strap all the equipment together? Well, but we've put all the equipment together. We've already built a comet. We've seen it on YouTube already. So you too can be the ones to see it. Now, but what I mean by we is the team building it. Nobody else has seen it yet. It was hidden. But maybe you could if you join the foundation. So that's where we stand. We've got 3 more modules after that. One based around water is life, one based around exoplanets, and a final one that's going to turn the astronomical lens back to Earth so the kids will get grounded back on Earth with issues that affect us. People love to know, what is NASA doing for Earth? Why should we care about that? Well, we're going to explain it. NASA observes the Earth the same way we look at the cosmos, and we're learning a lot, and we're going to show how important that is.
I just love it. David, when we reopen, is the plan to run both on-site and online programs in tandem?
You know, I'd like to. That's my plan, but whether we have the funds to do so, really depends on you, the audience. It depends on the folks that are here for Griffith Observatory, for our foundation members. I know the foundation would love to fund the in-person program and this new one. We love reaching people. We love inspiring them. But honestly, I know it's going to take money. And that's just, it's just a fact of life right now. And I only have so much staff. The city knows that staff, anyway, the limits that are placed upon the program inevitably come down to staff costs. And the foundation has been there to make our in-person program possible, because at one point the city said, can we afford this? We're not sure. And I know that you stepped in and said, no, this is too important. We're going to make this happen. And you did ever since then. So I know that you're going to be there for this new program if you can. So yeah, my answer is all that long answer of yes, if we can do it. All those words to say that much.
Well, we would love to be able to support you, support the observatory in both scopes, as well as in all the other ways that we can, and really reach a broad audience. So, David, thank you so much for having me tonight. I'm so proud of this collaboration and where we're going. I will take one last opportunity to invite viewers one more time. You can be a part of this impact, and if you join, you'll enjoy all that the observatory has to offer as a member. During closure, that really means an annual subscription to the Griffith Observer magazine, special access to video and other digital content in the members-only content portal online, exclusive virtual programming, and even parking privileges for members at the supernova level and above. So we've dropped the chat, in the chat, how to become a member, the link. I'll just say it's been such a treat to spend time with you all. Thank you, and have a great program tonight.
Well, thank you, Anne Marie. It was great having you here and letting folks know everything that you do to make so much of what we do possible. Folks love Griffith Observatory, and they don't even know that they're loving all that the foundation does for us at the same time. You're there right with us. It is a true partnership. So I'm looking forward to, things getting back to normal eventually. And when we reopen, everything we'll be able to do at that point. So, folks, stay tuned. There are great things happening at Griffith Observatory right now, and it's just going to keep coming. So thank you so much. Well, what do we have next here at Griffith Observatory with our All Space Considered? Oh, that's right. Let me back this up. I completely flubbed that, but it's going to happen at least once a show, I'm sure. We have a little video we put together that shows just how important the school program is. And our staff made some comments on this. I want to run this for you now. It's very short, but to put it in context of this is how important this new program really is from the staff that run it.
What I really love about this program is that we're actually talking live with the students, and their eyes light up when they realize we're real.
One thing I really like about the online school program is how we focus on direct observation. We try to show you a live image of the sun, which is a really good opportunity because not everybody has access to that kind of equipment.
The kids really love interacting with us and doing the polls, and it's really great when it's Q&A time. Their eyes light up, and man, they have some great questions.
Once upon a time, I was one of those fifth graders that came up here when they were in fifth grade and got to experience Griffith Observatory in person. To be able to give them something like that in this climate that we're in with a pandemic and being stuck at home and not being able to come here, just to be able to have something for them so that they can still get a little bit of that magic, to see their faces when we go into the room and answer questions, and to see the smiles and shocked reactions and all of that is really thrilling for me, and I think they get a kick out of it too.
Well, thanks, folks. That program is live. The kids know it's live. It's special, and stay tuned. And some of our members have actually gotten to experience it. So one more reason to become a member. All right, well, on to the Golden Griffies. I'm going to do this very quickly, probably a little quicker even than I planned to, just because I'm anxious to get talking Perseverance here soon. So first of all, the American Astronomical Society has a big meeting every January, right after the new year. And it's called by some, and I quote, the Super Bowl of astronomy. Well, this is also awards season. So being All Space Considered, being Well, you know us. We decided to blend the two together into what we call the golden Griffies. And tonight is the night we award the bronze, the silver, and the gold Griffies to the stories that were most popular and had the biggest impact at that meeting. So last month, I went through and I introduced all the stories. We created some teams. I gave some points for what we thought was important. Then we opened up the voting to you, the public. Well, you voted. You had a small influence. And tonight, I'm going to tell you who won. First of all, the bronze golden Griffy. Open it up here. Oh, this is impressive. This is really impressive. Dark matter and gravity. Dark matter and gravity sneaking in. Who knew? It wasn't expected to happen, but it did. This story here about globular clusters, which are clusters of stars, usually tens of thousands, hundreds of thousands to millions. Some folks even think they could be cores of galaxies. You're using them to trace the dark matter in a dwarf galaxy. So what does that even mean? Dwarf galaxies are little ones. They have tens of millions of stars in them generally. So they have some globular clusters. Well, they're mapping this dark matter distribution. You might hear more about dwarf galaxies next month if we can get our special guest, Dr. Michelle Collins here lined up. I believe we have that in the works. So you can hear more about dwarf galaxies next month. Next story, the background, gravitational wave background here at Earth. Now, what the heck does that mean? Well, gravity, as you know, can create waves in the very fabric of space-time. We've talked about it here at the Griffith Observatory's All Space Considered. Well, there's all sorts of stuff that makes gravitational waves, and there should be a continuous, constant background noise. It's sort of like just the average waves in the ocean. Sure, a big ship goes by and generates a big wake, and you could see that, but at all times there's these waves that are there. Well, folks want to pick up this background, and they think they might have. They're not sure they did, but 12 and a half years of data, they think it might be there. So an exciting result that got them the bronze. Lastly, the main story in gravity, the Milky Way's dark side. Of course, I had to include that slide just to say the dark side of the Milky Way. And of course, this looks like a lightsaber to me. I'm more of a Star Trek fan, although Star Wars is greatly entertaining. So, you know, we got these things that look like jets come out. This is a pulsar. And pulsars can be used I don't know why I'm going backwards there for a second, but pulsars can be used to detect the gravitational field of the Milky Way. In fact, that's what they did. They took the very even pulsing rate that we receive the light from them, and the slight variations in them was used to map out the dark matter of the Milky Way. So bronze goes to them. The silver, let's see what we have here and see how well I can open this up. Yeah, my faking ability here is second to none, you can see. Second to none, I tell you. We have, oh my goodness, we've got stars and nebulae. This is terrific. There was a study about some supernovae. They looked at it, supernova 1996. Well, what did it do? Well, it faded in X-rays. They measured the X-ray brightness. So they learned details about very young supernovae. Next one, about a jet coming off a star and a perpendicular jet, the backwards jet. Why is it pointing the wrong way? Has to do right down in here. There's very, very strong magnetic fields down near the center of that object, the neutron star that's creating this. Well, it ends up being synchrotron radiation. I know, who knew it was synchrotron? I just like saying that. Anyway, it happens when electrons spiral in very strong magnetic fields. They give off light, and they think they're creating this backwards jet as well. Very interesting structures. Finally, I think the reason this one came in second and won them the silver was the Jewel Bug Nebula on the left. Just beautiful, and you can see this structure in here, sulfur, iron, anyway, and dust extinction that's deep down in there covering the insides of it. This is a star that shed off its outer layers, what's known as a planetary nebula. The sun, when it dies, will go through a phase much like this. So the star, it gives off this outer layers, leaves a white dwarf down in the core behind, and they're seeing those layers of the star, the sulfur and the iron, actually are distributed differently in this nebula. So telling us something about how this star shed its layers and what happened. And another just beautiful nebula here, the Butterfly, and they did more work on that as well. And you can see the iron and the nitrogen, again, are somewhat separate from the dust. And there's information in here, and we're piecing apart how these stars die. So very beautiful. This is an emission nebula. They glow in these gases. Finally, the golden Griffy itself goes to, that's right, it's galaxies and cosmology, of course. Winner here, you're looking at the galaxy, a very, very luminous galaxy, giving off a starburst, superheated winds coming off the center. This is M81. I was looking for the Messier number. And it does indeed look like you have material that's being showered outwards, and it's being guided by magnetic fields. You're starting to get sort of a theme here. And for a lot of astronomers, research astronomers tuned into the show tonight, I know there aren't many, but the joke was always, well, did you include magnetic fields in your model? And now the answer evidently is, yeah, we did. And it's driving that material out. It's probably not coming back. So pretty neat they're doing this. And finally, triple galaxy collisions. Wow. Yes, this is the finale for our golden Griffy. This is what really won it. Triple galaxy collisions, what are you talking about? Well, yeah, galaxies collide. We see this all over the place. In fact, there's a great survey going on by Julianne Delcuntin, Dr. Delcuntin up at UW, where she's getting these amazing Hubble images of all these crazy galaxies. Well, this study went and looked at these triple mergers and thought, can we find black holes in them? And the answer is, yeah, you can. Galaxies have supermassive black holes down in the center, millions of solar masses all in one spot, so much that it bends light. Light can't escape those black holes. Well, as the material falls in, it superheats. When it superheats, it gives off X-rays. So where there's a black hole, funny enough, you get X-rays, some of the most energetic kinds of light, right before it turns black. So the very, 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 very center of it, sure enough, if you could resolve it like they did with our anyway, we'll talk about that later. I'm getting off track. But you see here, we've got some mergers. Are there some triples? Are there some doubles? How many black holes do we see? Indeed, there is a single black hole there. There is a double black hole. And there is even a triple black hole, supermassive black hole system. So that's what won them the golden Griffy there, the fact that they're seeing multiple supermassive black holes. And we're hoping eventually to see maybe 3 that might merge together. Although a triple system, what's really cool, sometimes one of them can get thrown out, completely flung out of the whole interaction, and you'll just have this random supermassive black hole cruising through space, which to me seems like you'd have to be out to launch to believe. I know, what a transition for you, Chris. Anyway, we're going to move along. Chris Butler here is going to talk about some launch news here. I know there wasn't a whole lot, but there was a pretty interesting event.
Yeah, now it's a little bit quiet right now. The later in the year, fans of launches, you keep your eyes to All Space Considered. We got a lot of stuff coming up this year, but there's something really exciting going on right now. Launches down deep in the heart of Texas, actually deep south in Texas, right on the border with Mexico. SpaceX has been testing its astounding Starship rocket. This is a gigantic rocket, 160 feet tall. That's a 16-story building. Nobody is riding on this rocket. They're just testing it right now. An amazing rocket system that can launch into the sky and is designed to glide back down for a landing. It's a reusable rocket. When it's all assembled and built, it'll be as large as the Saturn V moon rocket. This is a monster. And the tests have been, well, a little exciting occasionally. The last 2 times they tried this, it went up all right. It glided back down all right. But when it tried to turn its nose back up and land, boom, much excitement. Now, they just tried it again 2 days ago. I'd like to have a look and let's see what happened. There was much rejoicing. This giant water, like a water tank flying into the sky. That thing's 30 feet across, folks. 160 feet tall, launching all the way up to 30,000 feet, flipping over, falling back down, and drum roll please, how do you think it's going to go? Is it going to stick the landing, or is it going to explode? It turns around, it comes back down, flames leaping from the rocket as it tries to slow itself down, and a little bit of a bounce, but she's sitting there, she landed. This gigantic rocket has managed to land, a gigantic success. And 8 minutes later, it blew up. It just blew up. This is very satisfying. There's nobody on this rocket, okay? But wow, that's pretty spectacular stuff. And you may be thinking this is really bad news. Well, it's not what they had in mind, but it's not necessarily bad news. First things first. They're building a big rocket here. SN10 is labeled there, and you can see it's actually just the top stage of the entire Starship system. When they get the bottom stage under that, which is the one in the middle, it's going to be taller than the Saturn V moon rocket. So this is a big thing they're testing. Of course, it's complicated, and the Saturn V did a lot of things, folks, but it never had to land. Okay, so this is really groundbreaking stuff. When we look at the pictures of the actual test, we can see the 3 engines that are installed on serial number 10, as it is known here, firing to slow the rocket down in the last moments before landing. A little bit of a fire did break out in one part of it when they're shutting down one of the engines. Maybe not quite right. We're not sure yet. And it sure did look good, at least at first. But now a couple things to notice. It had little stubby landing legs that it was supposed to be sitting on top of. That landing was rougher than they expected. It's sitting flat on the ground. It's on the concrete, not on the legs. It squished the landing legs. So it hit a little bit too hard. It sat there for 8 minutes, something like that, and then kablooey. Off she goes into a gigantic fireball. We don't know what caused it yet, but it was pretty spectacular. Anybody think this looks like the Hindenburg? It does, but fortunately, there's nobody on this, so it's just a technical thing that they need to look at. Now, as a space program vet myself, I used to work on the space shuttle. I want you to know it's not that surprising to have something explode after it's landed. It's not surprising. It's something you have to guard against, and that's been true through the space program all along. If you look at the picture you've seen there, in the upper left, you've got the little XB-37 robot space plane the Air Force uses, and it's just landed. And you'll see the crew around is wearing hazmat suits and gas masks. And if you look at the bottom, you see an Apollo command module splash down the ocean. Well, the crew in the life raft is wearing gas masks. As a matter of fact, on that landing, the last Apollo landing, fumes leaked out of the rocket systems and almost incapacitated the crew. One of them passed out before he got his gas mask on. And then you see the picture of the space shuttle. Every time the space shuttle landed, you see that thing with the red circle? That's a big fan to blow away rocket fumes. The landing of a rocket, bringing it back, is very difficult and dangerous. So it might have been a surprise to some of you to see a problem after a landing. I just kind of nodded my head, say, yep, that's something you need to work on, boys. And don't worry, all the men and women at SpaceX are looking at it now. They'll get it figured out. And maybe someday in the not too distant future, we're going to see one of these monsters sitting on the moon or maybe on Mars. It's an exciting time to follow launches, so I promise you, I'm always going to be out to launch. Thanks a lot, Dave. Back to you.
Yeah, thank you, Chris. Wonderful work there, showing off what's going on down there. Although I did catch your reference to the Holy Grail movie, and you didn't leave me time to throw in.
We can't get anything past you.
Well, I was going to throw in, and then they ate Elon's minstrels, but I thought it might be inappropriate, so I'm not going to go there.
Well, today SpaceX was in the cave of Arg. But don't worry, they'll find the Grail. They just have to keep working.
They certainly shall. And Patrick might have the information in the sky to help them get there. Patrick, tell us what's going to be in the night sky.
Oh yes, certainly. So what's in our night sky this month? Well, we're going to turn to the morning sky where all the action is actually happening. You notice that close to the horizon, there's Mercury and Venus, and actually Mercury and Jupiter, and both of them are very close together. They're only about a half a degree or 1 moon's diameter apart. So look for that on the morning of March 5th. Also, the moon will be sneaking by and getting close to the planet Saturn, and it's just about 7 degrees from Saturn. And then it will move lower the next day, and also be roughly about 7 degrees from Jupiter. In the morning sky, if you get up a little bit earlier, you'll notice that there are lots of constellations that you normally see in the summer sky and even in the late spring. And one of them you can see kind of low near the southeast horizon, and that is Scorpius the Scorpion with its bright red star Antares, which in fact turns out to be Chris's favorite star. There he goes. He just acknowledged that. If you're not a person that gets up in the morning, we can turn to the evening sky. And right now, we can see that Orion, the hunter, and Canis Major has kind of moved over to the southwest, where they were last month, dominating the sky in the due south. We'll go to the next slide here. This is, it's really not too late to see Orion, and we actually saw a portion of the Orion Nebula, which is right below the 3 stars of Orion's belt. And you can see that kind of misty patch there. That's what we were looking at. There it is, live there. So that's what we were looking at earlier on, and see another. It's okay. All right, so we're going to go to the next slide here, because just to the east of Orion is the brilliant star called Sirius. And we have this wonderful picture taken by one of our telescope demonstrators, Anthony Perkic, showing Sirius, which is a star only about 8.6 light years from Earth, the closest star to Southern California, as seen from our locale. On the 18th, Mars and the Moon will be fairly close together, and they form a beautiful kind of quadrangle with Aldebaran and the Pleiades. So that's definitely worth watching for right after the sun has set. Now, don't forget this month on the 14th to turn your clocks back. Actually, no, I'm sorry. That's the other way around. Turn your clocks back, turn your clocks forward, sorry, 1 hour on Sunday, March 14th. Another thing that's happening this month is the spring equinox, which occurs on March 20th at 2:37 a.m., where the sun reaches the celestial equator as it begins to move northwards from that point along the sun's path known as the ecliptic. The spring actually brings the arrival of spring here in the northern hemisphere, but at the same time in the southern hemisphere, autumn begins. And with spring and kind of warmer temperatures, more daylight and blue skies and flowers, here's our moon phases for this month. And we can see here that we have last quarter on the 5th, new moon is on the 13th, first quarter is the 21st, and full moon is on the 28th. And that's all for the sky report. So enjoy and look out for all those wonderful objects in the night sky.
Well, thank you, Patrick, for bringing us that sky report. I do want to point out on the spring equinox, our plan is to bring you that celebration from Griffith Observatory. Stay tuned for more information on the website and what we're going to be doing on that day. But we are going to celebrate the equinox virtually. We won't be doing it in person, so don't plan on coming up to Griffith Observatory. It's not safe to be in big crowds, and we're hoping to get a large virtual crowd viewing with us here on YouTube and our other streaming platforms. Well, right now I want to turn to our wonderful feature of pretty pictures with Katie, and Katie's going to be here to tell us what we're looking at in all these beautiful astronomical images. And then we'll get back to the rest of our program right after this brief pause and all this information. Take it away, Katie.
Thank you. So these sets of images were taken by telescope demonstrator Anthony Perkic. We've already seen this one a few times, this gorgeous image of Sirius and Canis Major. These were all taken from Joshua Tree National Park on February 10. Here we have Scorpius rising around 4 a.m. And another beautiful image of Milky Way rising. This is galaxy M101, the Pinwheel Galaxy in Ursa Major. This is M91 and M88 in Virgo. And a stunning image of M67 in Cancer. Another gorgeous image, M5 in Serpents. And this is C38, the Needle Galaxy. M44, the Beehive Cluster in Cancer. And this is M109 in Ursa Major, gorgeous image. This is Markarian's chain. This might look familiar in the Virgo cluster from the Gunther Depths of Space that we have in Griffith Observatory. There are all of those galaxies labeled. And beautiful image of M51, the Whirlpool Galaxy. And these are our morning planets taken February 17 at 6 a.m. over New York by Alexander Krevenishev. And there are those planets circled so you can see them a little better. And by museum guide David Pinsky, gorgeous image of the observatory in Los Angeles taken on February 7. And a nighttime image of the observatory in Los Angeles by David Pinsky. Beautiful image. And finally by David, the waning gibbous moon, just after the full moon on the 27th. And our last picture of the evening is from Lauren Hughes. On Twitter, we found this image.
That is just wonderful, Katie. Thank you so much for bringing us those beautiful pictures. If you are an astrophotographer out there like Lauren and take beautiful astronomical images, tweet at us, send them to us, and maybe you can be on the show. Could be not you personally, but your image can be on the show virtually. Anyway, let's move on to our next exciting segment. I'm so thrilled tonight. We have Nikki Cox with us to talk about the Perseverance rover. Here to do a question and answer. But first, Patrick, why don't you take us through the steps Perseverance had to get to? She had quite the journey to get down to the surface of Mars. So what went on, and tell us about it.
Okay. Well, as you can see here, this is just a computer animated image of the Mars Perseverance spacecraft plunging through the Martian atmosphere at a speed of 12,000 miles per hour. I'm showing, on this diagram, I'm showing where it is on its entry, descent, and landing, or EDL. And at various points, the parachutes deployed, the heat shield dropped, and all the time there were actually cameras going on, recording some of this phases of the EDL. Finally, the sky crane took over, and on February 18th, the Perseverance was on the ground roughly about 12:55 Pacific Standard Time. It landed in a very narrow ellipse, and you can see it here. It's only roughly about 5 to about 4 miles in diameter, much smaller than any of the other landing ellipses from other missions. It's just incredible testament to the landing technology of entry, descent, and landing.
Yeah, well, that's just amazing. And I want to point out here, we'll see some of these features. You can see here the delta that was left behind by the river that flowed into Jezero crater, and also this crater rim. You can see a great big rim going all the way around. And now we're going to run the footage that NASA supplied. Some of this footage, in fact, most of it was taken by the rover system itself. and you're going to see some amazing things. So keep an eye out for all that, all the stages Patrick showed, and then keep an eye out for some of this landscape you're seeing in this image. You'll see some of it. So
we are
enjoy.
starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Applicant indicates chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Yeah, I mean, can you just say how crazy that is? You could see the reactions of these JPL folk, the cheering, of course, when it lands, the stress. This was celebrated across the country, of course. The achievement by our own mayor, lighting City Hall red. I know some buildings in New York were, other places. It was fantastic. Some of the photos that were sent rather quickly after that happened, that's actually the heat shield that's been ejected heading down there. You can see right up in here, there's that delta I was talking about, and over here's that crater rim. You can recognize features. If you studied Jezero Crater like I have over all these years, waiting for this landing to happen, watching it live and me recognizing some of these features, I was blown away by it. It was just nuts. And Nikki has joined us here. I see she's hopping in, getting ready to talk about some of this, but just amazing things. MRO captured an image of the parachute coming down. They did that with Curiosity as well, but watching the parachute system, I was always amazed with, but we got video of it. So who needs this picture? Okay, we do kind of, but still. This one though, Patrick, a lot of fun. What's going on here? Something interesting.
Yeah, as you can look at the parachute, you can see there's kind of red, there's a red and white pattern to it. And normally for descent parachutes, that there's basically even red and white stripes. So what's different about this? Well, actually, what's different about it is that those red and white patterns represent a binary code that actually means something. A few days after the press conference, Al Chen challenged the public to actually look at the coding in this parachute with respect to red and white and decode the message on this particular parachute. And we'll go to, I think, next slide here where we see some tweets there. And David, did you want to say a few things about this?
Yeah, well, I of course was on Twitter all excited, and I saw these. It was somebody I follow liked it. And this was the gentleman that first, with his father, solved this riddle that you're going to tell us what was solved there. Here's his picture. I love the fact he's a Frenchman. Anyway, it's the humor of the French, I'll just say. So congratulations to this gentleman for solving it. But Patrick, what was the solution? I'm going to forward the slide here, and you can explain what was encoded on this parachute.
Okay, so here is the answer, and it only took 6 hours for the gentleman to actually decode this. And if you look close to the center of the parachute, you can see the word there, and then a little bit further out, mighty, and then even further out is things. And then on the perimeter of the parachute, there are some numbers there. What does it all say? Well, this is what it says: "Dare mighty things," which is the motto for the Perseverance landing team. And the numbers there represent the latitude and longitude of the JPL visitor center. So that's the whole thing decoded in front of our eyes.
Well, thank you, Patrick. Just thrilling. I'm sure everybody out there trying to solve it was, anyway, amazing. But here is where Perseverance landed in that landing ellipse, almost dead center. But again, Perseverance guided herself down. Once the craft was getting near Mars, the systems were turned on, and everybody back here at Earth was just kind of getting the reports back. So there was a very sophisticated guidance system, imaging system, taking radar, matching everything up, and making sure that the craft came down in a safe spot, which is just incredible. Now, do you see in this picture that little tiny dot? Well, that's the landing spot. I'll move forward to one now. Do you see the rover down there? Well, here, let's make it a little easier for you. Perseverance is in the lower middle. The heat shield's off on the right-hand side, that little mar, and then you can see the descent stage. Indeed, the sky crane flies off away, diverts, so it gets away from the rover and crashes. And the parachute and the back shell are over off to the side there as well, up to the upper left. You can see here, there's Perseverance on the ground. There's some patches to the right and left. Patrick and I were hypothesizing this might be an infrared image. Maybe that was some heat where the surface was warmed up, or is Mars really just that white in this band? I'm not sure what wavelengths these are taken in, but fascinating to see the rockets of the sky crane interacted with the surface and blew that away. So that gives us a picture of what's under there at least. So I'm sure the scientists will use that to their use that information. Now here you can see where I believe that's the back shell and maybe the heat shield where they hit, but they leave dark Mars on the surface. There is the cloud, the smoke that came off of where the sky crane crashed. Indeed, I love that the rover was able to turn and look at what safely brought her down to the surface and take a picture of the aftermath. I was always curious, what does it look like? Well, sure enough, it leaves a plume right there, just sitting there, just crazy. Dear Mars, sorry for the litter. It was Mac's remark about it, which is funny, of course. But anyway, but I'm not too sorry about it, honestly. I'm glad to have a rover down there on the surface. Images like this, just nuts. Wheels on the ground, one of the first things you want to see, what are under your wheels. In fact, one of the wheels, I'm going to hit the space bar here. It'll work a little easier. One of the wheels landed right on a rock, pushed from the ground. Curiosity on the right-hand side recently rolled over a rock too, tipped it. You have to go look under what's under that rock, maybe. Maybe there's a scorpion, a Martian scorpion. Okay, doubt that, but still. The views from the new, hazard cams on Perseverance are beyond what, of course, most of our cell phones are capable of doing. And these gorgeous images of down low on Mars with the shadows and the rocks. And you're already seeing different types of rocks. And this isn't even a This isn't a science image, and you could do science with it. It's incredible. There's shots, of course, the rover deck. You want to be looking at how the instruments are and what's going on there, and what do they look like. And you also see targets down there on them. There's a target there that has colors, calibration targets for the instruments. They're very important to make sure everything works right. This one here, the wind sensor, they've learned, well, you need to package it in a way to keep it safe. And sure enough, it was spring loaded, much like the Switchblade. There was a frangibolt on there. Maybe we'll ask our guest what a frangibolt is. It's such a funny name, but it makes that pop out possibly. Panoramas on Mars being taken. Just go to the website and look at them. You can zoom and zoom and zoom and get more and more detail. See that little square off in the distance? That's a rock that's been shaped by wind in the panorama. You can't do that with the Curiosity panoramas. I love those, don't get me wrong. But these ones, the Mastcam Z ones, are a whole new game. This is all new for us. So again, look at this panorama. And here is a zoom from one of the pans. You can see the crater rim off in the distance. Here's how these are put together. Literally, it's a lot like you do it. You take lots of images and you stitch them together into the whole picture. So one after another after another. Here is Mastcam Z stitching together the landscape around Perseverance. It's kind of a fisheye view, keep in mind, in this projection. So the rover will be in the center, and we'll see, here comes Perseverance filling it in. Now, you might wonder, well, what does this look like? How do you often see it? Well, NASA stretches it all out for you and gives you this picture. And that's why the rover looks so distorted and so weird, because it's that, but the horizon is now made nice and flat, and each of those images goes into it. Now, I'm dreaming of the day, and maybe it won't happen quite like this, but if Perseverance rolls up on something on Mars that looks like this is a stromatolite. This is basically the evidence of ancient Earth life, some of the first life on Earth that was leaving behind signs that you could see. And these structures last billions of years on Earth. You can go to Australia and find them in places. So if we roll up past something that looks like this, boy, the scientists are going to get awfully excited and are certainly going to want to go take a sample and cache that sample and bring it back. We have instruments on, we as humans, as people on Earth, we have instruments on the craft that can study and piece apart and maybe even tell us that, yes, there are signatures that life created these ratios of chemicals and things. So extremely exciting work, but I love to say that, you know, we're all like Percy on the surface of Mars now, rolling along, listening to Fleetwood Mac and drinking it was a mocha pot there actually, so drinking our coffee. Well, Patrick, what is the sky at Jezero Crater like for Perseverance? Before we turn to our Q&A, Patrick is going to tell us what it is like at night there on Mars, which isn't at the same time night here is here on Earth. So that's a little hint about one of the things we're going to talk about with our guest, that night and day it's something different. So anyway, Patrick, what would you see if you were there at night?
Well, we're actually looking at it. This is the morning sky seen from Jezero Crater, from the vantage point of the Perseverance rover. And beautiful because it's the clearest skies and the darkest skies. There's no light pollution, and the atmosphere is only 1% of Earth. But talking about Earth, we're going to just put some labels here, and you can see if you look just to the east, indeed, just 40 minutes before sunrise on Mars, Earth is visible. It's up just above the east, above the star Antares in Scorpius the Scorpion. If you're looking for the North Pole, it isn't what you think it is, because normally what we do is we take the Big Dipper and we locate using the pointers, we find Polaris. In fact, the North Pole of Mars from this location is way down here in that red circle, North Celestial Pole. And it's close to a star called Deneb, which basically circles around that area of the sky, and is basically a circumpolar star rather, that never sets. The next nearest star is the star in Vega, in the constellation of Lyra the Harp. And here's a look at all the constellations you can see in the early morning sky. And that bluish glow indicates the bluish sunrise that you would normally see on Mars. Mars has sunsets also kind of bluish. So incredible view here.
Well, thank you, Patrick, for that. And Night on Mars is certainly interesting. And now we have our guest tonight. Thank you, Niki, for being so patient with us. We're running even later than we thought we would, but there was so much great stuff to talk about. But you've been present. You are the engineering operations deputy team chief at JPL for these rover operations. You've been with all of these rover teams, every single one of them. I know you've been in the landing area in the control room. Were you there for the landing of Perseverance?
Well, first of all, thank you very much for inviting me, Dr. Reitzel and Patrick. So I'm really glad to be here. I actually haven't worked on every single rover that the U.S. has sent to Mars. I was not on Pathfinder. So Spirit and Oppie were my first. I was actually on Galileo at the time of Pathfinder's landing. And so I love, any chance to look at Jupiter photos, Jupiter pictures like were being shown earlier were wonderful because, I'm also a Jovian. You never forget your first mission. And for me, that was Galileo. But I have been fortunate enough to be in the control room that you guys saw that we were just seeing some images of on Spirit, Opportunity, and Curiosity, because on those missions, I was working as part of the team that flew the mission from the Earth to Mars. And I later went into surface operations. But for this mission, I've been focusing on surface operations. So I was part of the team. I am part of the team that was preparing for and now executing surface ops. So on landing day, what you saw, especially because of the pandemic, everybody's kind of spread out. So there were two control rooms, one for the team flying us from the Earth to Mars, entry, descent, and landing. And that was what you saw some images of. And then on the second floor is another mission control area, which I'm kind of sitting across from now, where the surface operations team takes over control of the rover once we got on Mars, and that is operating it now. So,
well, that's amazing. Now, I have a question for you. I didn't show any pictures of Percy rolling around. Has she rolled? Has she moved yet for us?
She has. We have dirt on our tires, right? And so that has been, and the odometer, right, now says 6, now say it's not 0, right? We've now gone 6.5 meters. And given that I still work on Curiosity, although I'm taking a little hiatus for landing here, I thought about the poetry of the fact that Percy's wheels moved on Mars. We started our first drive almost literally at the same time that Curiosity was crossing I think the 25-kilometer mark, I believe it was. That's what it was, focusing on this rover. So at the same time, we're getting started with our new rover. And before I forget, I want to say to Patrick, I have no idea what time it is. I'm so confused by time that I really have to thank you for saying there's a time change on Earth next week, because I literally just wrote that down. I was like, oh my gosh, there's a time change on Earth next week. And thank you for saying that. I will also remind the team here, because that's like so far, we're just the whole time thing. So thank you for that reminder. I wrote it down.
Remember, just spring forward.
Yeah,
that's the key.
Yeah. Well, on top of that, in fact, Matthew, if you want to go back to the slides here, Mars is on a different time than Earth is on, and we have a couple of little graphics here. And this one, I think I had it figured out. It shows Earth time, then it shows local time. I think we've got UT on there, but then there's a Mars time. But then there's also time for several locations on Mars. So it looks like, are there time zones on Mars? And which Martian time zone are you on? And how is time on Mars different than it is here on Earth? Because you had told us when we first started to arrange this, you were on Mars time and you weren't sure whether you were going to be able to make it. Well, we looked into it and realized, indeed, there's a difference here. In fact, it looks like Mars time drifts by 39 minutes a day compared to our time. So
that is true. That is true. And in fact, because we get a lot of opportunities to tell these stories, but I have to say that there aren't very many of these requests that a lot of them we have trouble scheduling because of the time. And then when I realized that this one, the timing of this one, I thought, oh, okay, but it's Griffith, right? So I'm gonna, and literally right after this, I'm gonna go home, go try to get a few more hours of sleep, because right now it is 2:10 in the Martian afternoon. And we are night owls on Mars. So the Martians, we sleep during the Martian day. And so in this case, I would normally be asleep. And okay, so the rationale for that, as Dr. Eidzel said, was the Martian day is approximately 40 minutes longer than the Earth day. It takes longer for Mars to rotate than the Earth does. And it's that difference that forces us to, when a rover first lands on Mars, we have this multi-billion-dollar asset on Mars, a priceless asset that is the hopes and dreams of scientists and engineers and the public all over the world, right? So we want to make use of every moment of time when that rover first lands. And in order to do that, we have to truly work remotely on Mars and live on the Earth, but work as if we're on Mars. So that means that our workday usually starts around 17:30, so 5:30 p.m. Mars local solar time. So there are not currently time zones on Mars, right? That is something that is becoming, clearly we're getting to the point where eventually we need to start thinking about that. But right now, time is defined locally. The same way on this planet, before there were time zones, each kind of village, each town was self-contained. And if you were like, well, what time is noon? Well, noon was defined locally by when the sun was overhead. And that's the same thing we do now. So where Curiosity is, her time is defined by when the sun is overhead at her landing spot. Same for Percy. The same was for Spirit and Opportunity. So right now, that's why it's a local time. Okay. And thus, we move 40 minutes each day, right? So our shift time tonight starts approximately 40 minutes later than it did yesterday, in order for us to track this, to track the time on Mars. There's a little bit of a complication in that now we have all these great orbiters, these orbiters around Mars that relay our data to us. And so that sometimes affects our shift times as well. But yes, right now, and we do this for 90 days, that 90 sols. So a Martian day is called a sol. And what's important to point out is this shifting schedule. We'll go through this for 90 sols. And again, the reason we don't do it for longer is because it's really hard on the humans. It's hard on their families, it's hard on themselves to basically shift a time zone every day for 90 sols. And after 90 sols, normally in non-pandemic times, we're all together, we're learning to work as a team, and then the team starts to distribute with the science teams going back to their home institutions. And we're like, okay, great, we all work together for 90 sols, and we move into more of a modified Earth time, where the first goal is to try to sleep during the night and gradually get to something that's more sustainable for the humans that are working on Earth but remotely on Mars.
Okay, well that's pretty complicated. I know that we've got a meridian arc at Griffith Observatory that tells us when local solar noon is. Now, I'm sure you're just using mathematics to tell you what time local solar noon is. I don't think you shipped a meridian arc like the one we have in our Gottlieb Transit Corridor at Griffith Observatory to Mars with each of these rovers. But that makes sense that you would use local solar time to define that. That makes complete sense. Now, what are the next milestones coming up that we should keep an eye out for for surface operations for Perseverance? And what are you looking forward to?
So, it's a remarkable time, and we were just talking about this yesterday, in the way that it's on the one hand, you're planning for operations, you know what you're going to do during this commissioning period, this time when we're getting everything checked out. But then there's kind of the emotional aspect, right? Every time we would plan for what we were going to do now, but in our hearts there was always, the don't count your chickens, right? Because landing has to go well. And so when the further out we talked about, Sol 14, Sol 20, there was always it seemed so far in the future because there was this giant event in between us and surface operations, right, which was landing. So the fact that we are now past some of our initial checkouts, that we have transitioned to our surface flight software, which is huge, that we've done the initial drive, right? We have dirt on our wheels, and now will actually be what's coming up is we're starting to think about the helicopter. And one of our next drives is in fact the one that some of the data that'll be coming down today is let's see, that'll be coming down, and here you go, here's the thing, that'll be coming down to Sol, but tomorrow to Sol, but tomorrow, right? Meaning it'll be coming down today on Mars, but tomorrow on the Earth. We'll hear how this drive went, where we're starting to check out the airfield for the helicopter. So we're looking, the scientists and the helicopter engineers have been looking at where should we drive to do the helicopter activities, the first month of test flights. And so that's very exciting. So we're going to be getting ready for helicopter activities. We're doing more instrument checkouts, more mobility checkouts, and we can also start to see that after we do the helicopter activities, after we do the helicopter test flights, we will be checking out the sampling system. And so it's really something after years of preparation to actually see these capabilities coming online on Mars after being able to see that spectacular video. It was so great to have a chance to sit here and watch that landing video again. Because I've worked on these missions where on Spirit and Opportunity, we'd get like one image. Wow, there's us on the chute, right? Oh wow, there's a picture of the heat shield. And now to see this in video form, right? I was in the surface operations area when that first image of the rover on the sky crane on the bridles came down, and I mean, the room came unglued, right? Just unglued to see these images that show us in such detail what's been in our mind's eye and in our animations for so many missions. It's just fabulous, just fabulous.
I never thought we'd be seeing that sort of video coming live from the surface of Mars, and a new standard has certainly been set by everyone. We did have one question from our stream, and folks, I want to apologize. I guess there is a noise that they're hearing that sounds like a USB stick getting plugged in and unplugged. I guess it's a ding. We're not hearing it in our own return audio that comes back to us. So I'm sorry I didn't know anything, but Matthew, if you're hearing anything in the control room, if you can fix that, that would be great. I'm sorry, folks, I saw that in the chat. Anyway, there was a question for you. Why send something to go get the samples in 10 years? Why not just send a new craft and get new samples? What's the advantage of having Perseverance gather the samples and then having a different mission retrieve them?
Well, so that's a great question, right? The fact that the Mars sample return is a three-pronged campaign, right? And one of the things is the time it takes to traverse this. I mean, we have a multi-Earth year mission and to get these samples, and then what we hope is an extended mission to continue our exploration And while we're doing that, again, it's part of the way we architect these missions, where you learn from the mission that's gone before you. And so we've learned from curiosity about these habitable environments. We have improved our landing capability to where we can go to these particular locations. And yes, an argument could be made for, for kind of sending two missions in parallel, so to speak, where one was landing and doing the sampling, and then the other, is kind of getting ready to return the samples. But part of that is also our goal is to get this moving as quickly as we can. Right. And so now that we know that there's these habitable environments, to send the next rover and start the process of collecting these samples. Developing the sample caching system was very complicated. It's the cleanest thing that we've ever sent to another planet. And so there's always learning curves that occur in these missions where you're like, can we build this on time? Can we launch on time? In the pandemic, right, it was not clear that we were going to be able to launch right when we did. That's why the rover carries kind of a thank you to the essential workers that helped us stay on schedule so that we were able to launch this year, land, and begin the multi-year process of picking samples, which is going to happen in parallel to the other mission being developed and sent. And so it's about trying to get these back as quickly as possible. And so if it had all been done in one mission, then you would have had kind of one mission that was, where you landed the rover, that went off to get the samples, came back and gave them and put it in the Mars, the Mars Ascent vehicle that's going to launch those samples back to the Earth. Again, that would mean that you're spending a year or two collecting those samples, and the rovers are actually very different. So this rover is responsible for collecting the samples, and this rover is like this mighty collection of payload and cameras and capabilities that allow us to find the best samples to bring back. The next rover being built by the Europeans that will launch not long from now by engineering standards, just like 2025, 2026 is the target. So 4 or 5 years from now, the 2026, the sample fetch rover is very different. Its capabilities are drive, pick up the samples, bring them back to the Mars Ascent vehicle, a very different rover and mechanisms and objectives than what we need for the science objectives of picking the samples. But that's a great question.
Yeah. In fact, the other day, people were wondering, and we had a discussion on our team about why don't we just keep the samples on the rover itself? And then we thought, well, if you want the rover to go drive off and go up hills and go explore this delta and do all these things, we might go up that riverbed. You never know. That's not a great place to go land to pick up samples. So you're better leaving those samples in a location that's easy to get to and make the next mission to retrieve them have a shot of success. You don't want to try and land in a little riverbed where you have rocks and boulders and all these other things, yet you can drive a rover through that terrain.
Right. That's a good point about the additional aspect of then if that rover that is getting the samples has to leave enough margin and time to get back to the vehicle that will then take the samples back to Earth, the way that constrains the mission again is very different. The other piece of what you were saying is it's absolutely about leaving, kind of saying, oh, this is a good place to leave a stash of samples so before you kind of venture off. But also one of the reasons we also don't store them within the rover is because mechanical failures happen, right? And this is going to be a literally priceless sample tubes. And the last thing you want to have happen is because the rover has has an extended mission, that those tubes get like stuck in the rover. And so that's why you want to take your samples and then periodically cache them. It's a little like the question that always comes up about Spirit and Opportunity. Why didn't you put something in that would clear off the solar panels? Or why not be able to flip over the solar panels? Every time there's an engineering improvement like that seems obvious to situations where, if you had astronauts or situations on the Earth, when you're doing things robotically, you have to consider the failure modes. If you have solar panels that you flip over, and then brush off what if they don't flip back over? Right? You have to think through the possible mechanical failures and then say, for the basic mission, do we need to take that risk? Do we need to keep the samples within the rover, cached in the rover for the entire mission when there's the possibility they could get stuck in there? Small possibility, but that's what the engineers think through, is this chain of events with this priceless return samples.
Well, thank you for that explanation on that. That is indeed fascinating. And the update on the helicopter, we're all excited to see Ingenuity take off and fly. Will we get live video and audio of the helicopter flying? I know there are microphones. I know there's video cameras. We've heard some wind noises already, I believe. There was a question when we're going to hear the wind, and I think the first sort of buffeting against that microphone has been released. But are we going to hear the helicopter go and fly?
So we won't. So yes, we have heard the wind, the small movement, and that was another moment in the control room where, it seems like literally a small thing, like the wind buffeting, and yet it was the unlocking of another sense, another human sense on Mars that we're now experiencing robotically. And to hear the planet, for all of us who have been exploring Mars remotely, it's such a visceral human experience to hear something. And so for the helicopter, there will not, the question of, so the data link back between the helicopter and the rover, again, focuses on these test flights that we're doing, these, 5 to 10 test flights in the heli month, as we're calling it, is where each flight makes another change. And, the first one, of course, will be the first powered flight on another planet, the Wright brothers moment. But after that, and so the data link that returns data from the helicopter is focused on the health and safety information of that. Are we going to have real-time video? I mean, I don't think so. I could be wrong about these things because where the focus is right now, but I don't believe that there's going to be real-time video. The rover, it's so cool to have a friend with us, right? As opposed to, we always feel we see the memes and we see the tweets about the rover being lonely, right? And we anthropomorphize these rovers so much that it kind of, gets us right there when we see these things. And so this time we're like, oh man, at least the memes will say, that Percy has a friend and the tweets. And so it's great to have this that we're going to be taking pictures, that the rover will be taking pictures of Ingenuity as it does its flights, and we'll be the tourists kind of, seeing what happened and documenting. But how much of that, again, with the data link? Well, first of all, the data link back, the heli has a radio connection back to the rover, and then the rover sends that information back. So we will be getting much more than images, but I don't think it's real time.
Okay, well, even if it's down the line a couple of days later, I don't care. I mean, this is phenomenal territory that we're in to be seeing this sort of stuff. Now, I have my eye on the clock here, and I told you we'd let you go by 9 o'clock because I know you've got another thing to get to here in just 5 minutes now. So I'm afraid we need to say goodbye to our guests, but we're going to have you back.
Well, and David, I will say that I moved the other thing, so I've got about another 10 minutes.
Oh, do you? Well, wonderful.
Yes.
Let's hang out. I know that we've got this opportunity here, so to speak, and the spirit to keep going. Okay, I won't keep this up. That's a Mark Pine joke. Hi, Mark. I hope you're out there. Well, folks wanted to know where my cosmic kitty is. I don't know where she is. Her brother's down at my feet at the moment. Maybe he's causing my cords to connect and disconnect. I doubt it. There was a question about the sample return rockets and the question of what they would use for the rocket power itself. Would it be a methane powered, which would leave behind certain things? Would it be hypergolic? Are there thoughts about that yet? How we'd get off the surface?
Yeah, so what the MAV is going to use, I mean, I believe right now the plan again is for kind of a traditional propellant of the hydrazine and yeah, so a chemical propulsion as you'd expect. There have been discussions about what could we use instead, and we are not to the point, as you might expect, of creating any of that on Mars, right? We have we're carrying an instrument with us, MOXIE, that is our attempt to learn our prototype of the oxygen generator, the oxygenator from the movie The Martian, where we take the carbon dioxide, Martian atmosphere, pull it apart into oxygen and carbon monoxide. And we are doing the checkouts for MOXIE now, but we haven't made puffs of really exercised the process yet. And so that is not obviously going to be online in time for us to make the propellant that we would need to send for the MAV. And again, that's a whole different set of connections. So what I want to say about that is the chemical propulsion that we'll be using for the MAV is the traditional right now. But the other thing about that is I want to again point out how soon this is, and that's definitely something from our end that may not be the same as the way our customers, right, the public see it. Is they're it's reasonable to say, wow, the earliest that the samples might come back is 2031, right? Whereas what we're thinking is it's 2021. And the next mission launches in 2026, right? That's not very long at all to build the rover and fully test something as new as, let's go get samples from another planet, deliver them to a lander, launch that off the surface of Mars and into orbit. And of course, the flight times are the flight times, right? And so once we're in the air, 7 to 9 months to get to Mars. But this is not, to us, this does not seem like a long timeline at all. It seems like, oh man, right? And an impact that has on surface operations is that, we've just gotten to Mars, right? But we have the team of engineers that built this rover, flew it to Mars, and is starting to do surface operations. And so these next missions are already going, okay, come on, right? You got to come build this one. Right. And that's one of the things that factors into our daily lives, is that the same people who have the expertise to build and deliver and operate these rovers are also are also the people who need to be working on the next one. So just in case I don't get another chance to say that, a shout out to everybody who's out there, including those who are, thinking about their path in STEM, is there aren't enough Martians on this planet to do what we need. So, so thanks to institutions like Griffith, which is absolutely our partner in returning this data and bringing it to the public, right? It's part of the reason that I would get up in the middle of the Martian day to come do this, is to say thank you to Griffith for sharing this information and also inspiring the people that we need to do these jobs. We just named the rover landing site, the Octavia Butler landing site, and that followed the tradition of Curiosity, where it was to honor a science fiction, like the Bradbury landing site for Curiosity. This is the Octavia Butler landing site because we want to acknowledge the role that public science communication and science fiction play in inspiring the people that are doing the job right now and the people who we hope will be doing the job in years to come. So just in case I didn't get a chance to say that, I wanted to say thank you.
Well, yeah, that is absolutely true about the inspiration and how we can help there. And thank you for pointing that out, although we play a small role. You make it easy. The NASA engineers, the folks that really do the work, you're providing us the tools like never before for us to inspire. It's just, you show it and it's inspirational. And I just want to comment here. Maybe people don't know, but Tony Cook, All Space Considered's Tony Cook, has been in the chat all night long, cracking jokes, dropping information, explaining things to people. We, Tony, it is a pleasure to see you join us here virtually over the chat. Just a shout out to our colleague, Tony. We miss you. I hope you're having a great retirement. I haven't seen Laura in the chat anywhere, but Laura, you're welcome to chat in there too. But Tony, so much fun. And one of the questions was, people wanted to know why were there 6 wheels on the rover? And Tony answered it. Part of it is stability, but part of it, if you go over a really steep rock, you've got those wheels in the middle, so your center doesn't run into that rock. You're able to go over some steeper terrain and things that have bigger curvatures. Is that the whole story? Would 8 wheels be better than 6?
It is. So that is a question we get a lot about, quite kind of why is the suspension system looking like this? And I'm sorry, I can't see the chat from the view I'm in. So thanks to those who are answering those questions. But it is a trade, right, between the fact that we need torque, we need the ability to go over these obstacles, we need the ability to also move in what is frequently not a very warm environment. And all of those things result in a system, this rocker bogie system, that the 8-wheel option has been looked at. And sometimes if you look at future mobility, it's more like kind of insect based, like what if it's more like how spiders move, et cetera. But this system is one that gives us, the ability to actuate the different, as was said earlier, to actuate the different wheels to recover from issues like Spirit and Opportunity had, where Spirit was dragging, one of its wheels and being able to drive backward. The trade-off there is from a power perspective, right? If you add wheels and actuators and motors, again, there's also an increased power draw. So that isn't the reason we don't have 8 wheels, but the 6 wheels is kind of the rocker bowie is kind of the sweet spot in the trades we have to make between power draw and also the speed. we aren't like speed demons, but we are expecting to go faster on this mission because we have more ground in the loop, more autonomous navigation capabilities, because that same computer that we saw earlier in the animation that allowed us to adjust our trajectory as we were coming down on the chute, the terrain relative navigation, it's that same computer that, in fact, one of the things I'm thinking about, you mentioned what are the things that we're doing right now. And so part of what we're doing right now is taking that computer that was put on board to improve entry, descent, and landing, and we still have the computer, right? It's in the rover. It didn't leave with any of the other hardware, and so we are literally reprogramming it. So as right now, in order to do its surface job, and its surface job is to help with the mobility, given that it has this take an image, process it quickly, and feed that back into a decision algorithm. That's exactly what AutoNav does. That's exactly what we need to be able to drive autonomously farther using this 6-wheel system, but to try to get us to be a little bit faster than our predecessors. And so I think that's a great example of recycling and reuse, right? Is to repurpose this computer from EDL for driving.
Yeah, Chris,
I wonder what your top speed is.
How
fast?
Sorry, say that again.
How fast?
So, our top speed, a good way to kind of remember this relative to people is, we're like a 10-hour mile. So if you think about how long it takes you to walk a mile, right? I mean, if we're kind of, going along, and not running, 20 minutes. And if you're truly stopping to smell the roses, right, that's 30 minutes. And, consider that we are really stopping to smell the roses in that we are exploring Mars. That's part of the reason that it's not entirely about speed, right? So if we meander on this planet, we're like a 30-minute mile, and the rover is about a 10-hour mile, right? Because we go about 0.1 miles per hour. So our distance each day, if we have a driving window of an hour or two, you know, we're looking at 100, maybe 200 meters a day, kind of outside, is the distance we will plan to cover in a single sol. So.
Trying to do the math there, and I think I came up with something like you can go about 10 feet a minute. Is that about the speed to get a tenth of a mile per hour? That would be 5,280 divided by 10 is 500 and whatever in an hour. So, you know, 50 some, you know, dividing it out, it's about 10. It's a little less.
Yeah, it's about 9 feet per minute, right?
9 feet per minute, yeah.
About 9 feet per minute. And so, you know, there's some funny comparisons with like turtles, you know, and sloths and things like that, right? So, but again, the trade there is everything, the power, the temperature, and the ability, as we were just starting out by saying, of going over the obstacles. So.
Yeah. Well, and what's the rush, really? This is the first time we've ever been here.
So lots more good stuff to come, and I look forward to joining you guys again, and hopefully it'll be a little bit easier once we get off Mars time to not have to have Patrick and Dr. Reisel work so hard, and Katie, thank you to get this timing to sync up.
Well, thank you for joining us. I know our audience appreciated it, and it's just a real pleasure to have you here.
Thank you.
We're going to bring you back for sure. So
thank you, audience. Thank you.
See you next time. So we're going to end tonight. I'm just going to go to the end of the show here slide, but I'd love to bring up, if it's still available, that telescopic image. Are we still able to take a look at the telescope? We sure are. This beautiful image of the Orion Nebula. We can gaze at this as I thank Patrick. So thank you so much for your wonderful job tonight. Chris Butler, your wonderful, you know, out to launch report that you're going to keep coming back and telling us more about. Thank you. Yeah, absolutely. Thank you, Anne-Marie Betke, for the support with the Griffith Observatory Foundation and all that is done to make shows like this possible and make views like this possible. And if you're not a member right now and you've enjoyed this program, I see there's still over 100 and whatever people are on our stream right now still watching. If you're not a member, I recommend you join. There's even more programming coming, more opportunities, and you can know that you're making this possible and helping make the school program possible and so much more. So thank you. Donate if you're already a member. You want to give a little bit more if you like the show, just please do. Anyway, thank you, gentlemen. Thank you, staff that makes this possible. Katie, wonderful job as always. Matthew, our switching. James and Geo up in the Telescope Dome, thank you so much. And to the rest of our crew, we have a whole giant crew. Well, not giant, but a lot of people that make this show possible behind the scenes. You're all the best. Thank you so much, and we'll see you next month at All Space Considered on the first Friday of the month. Thank you, everybody. Good night.